Okay, for this video, we are going to have a very basic wiring discussion about the Arco Zeus. It's going to be in three parts. One is going to be the wiring to the alternator. Second, the wiring to the battery. And then the third, we're going to have a discussion about the networking with the Arco Zeus and various things like Victron and so on. One thing to note is that I was involved with the development of the Arco Zeus for the last year and a half. It's been an exciting project. So to get right into it, there are two harnesses. One is defined as the battery harness and the other one is defined as the alternator harness. There are wires from each harness that need to go to the alternator. So let's start with the power. These are the power leads that come from the battery harness, and then these are the power leads that come from the alternator harness. The idea behind having two different sets of power wires was that if someone wanted to be able to shut down the regulator when the boat is not in use, they have the ability to do that by putting the regulator power on a switch. But in most cases, we end up powering the Zeus. We end up butt connecting these wires together. So one set of wire is to power the field, to energize the alternator to create power, and this one is just the power of the Arco Zeus. So typically we leave them on, and so what we would end up doing is butt connecting these together, and we use reducing butt connectors, and we could include this as a kit. So one side has a yellow ring and then the other side has a blue ring, so you can effectively put the two wires on the one side and then come out the other side with a smaller wire. So then this would allow you to extend your wires to go to their termination point. Now, speaking of termination point, if we use this method, this is an isolated ground alternator by American Power System. Isolated ground means that there is a positive terminal and there's a negative terminal. On a case ground, you only have a positive terminal because the return energy goes through the case, through the engine, and through the lead, the negative lead that comes off the engine. But in this case, with an isolated ground, we would put an inline fuse at the end of this wire and put it on the positive terminal above the main lug. You definitely want the main lug of the alternator to be on the first lug on the stud, and then you can put the positive leads with an inline fuse up to 30 amps, or based on the wire size that you have, and then the negatives lead we can put right on the terminal. Now, this is an American Power System. This black wire also needs to be terminated with a ring terminal, and also, you might have to extend it a little bit, but also put it on the negative stud. While we're speaking of these two terminals here, we always install an alternator protection device by Balmar. It's, I mean, it's not a guarantee, but it's cheap insurance. If the battery BMS cuts out, or if somebody inadvertently cuts off a switch, what happens is that energy has nowhere to go, and the result is a voltage spike. The higher the voltage of the bank, the higher the spike. But in a 12-volt system, this voltage spike suppressor can definitely help prevent damage to the alternator and potentially other electronics on board. So we've got our power wires that go to the alternator. Following that, we're definitely going to need a field wire. The field wire is basically what energizes the magnet inside the alternator, and it starts creating the electricity. That's basically what the Zeus is controlling. It's controlling the amount of magnetism within the alternator that creates the electricity. So we put that in. Typically it's blue on the American Power System. Here it's green. So here we would connect that to the green wire. And then the white wire, it's not always white. And again, these color codings are not always standard. Like I said, this should be blue, but it's green in this case. And this is white. White is for your stator wire, stator signal. And the stator signal is for the RPM measurement. Now, on some models of engines, the RPM gauge of the instrument cluster depends on this to be able to display the RPM. On newer engine, common rail engine, that's all digital. That's so it doesn't need this to be displayed on the instrument cluster. But for the Arco Zeus, so it knows what the RPM is, we definitely want to connect the stator wire, which is the white wire, to this. Now, if your engine depends on the stator wire for RPM. We also butt connect together, so we send the stator signal to the RPM gauge, and we also send it down to the Zeus. Following that, this is the brown wire is the ignition source. So basically, when you turn on your engine, ignition is on, and this also signals to the Zeus, hey, we're getting ready to charge here, something's going to happen. It basically allows the Zeus to be in charge mode once the engine starts. Otherwise, the Zeus can't do anything. It can't energize the fuel. It can't produce energy without the signal from the ignition. Now, on Yanmars, for example, there's a little T connector that has a blue wire and a red wire. Typically, it's the red wire. It's just a matter of grabbing a multimeter and finding, turning on and off the ignition, finding a source that has power when the ignition's on. We've tapped multiple different locations for this. Like sometimes there'd be a fireboard system, so there's a relay on the ignition for that. There's on Leopards, there's a bunch of relays in the back that are also tied to the ignition. So basically anything that's reliable tied to the ignition that is on at all times that the engine is on is a good source for this ignition wire. There is another set of wires, and this is optional for the Zeus. It's optional, but it's also a really nice feature. It's the alternator shunt. So with the alternator shunt, it allows you through the app to be able to see exactly what your alternator is producing. It can be good in troubleshooting to wonder if your alternator is actually producing, but it's also kind of nice to see what it's producing. If you're using it as a generator mode, and you can fine tune the RPM to see where the sweet spot is, where you're satisfied with the amount of energy that comes out of it. So there's actually a positive and a negative, or a high and a low wire, but the app has a feature, a switch, that will reverse that within the app. So it doesn't really matter which wire you put on the little set screw. You just put a little ring terminal, put it on the set screw. If you need to extend these wires, it's recommended to use a shielded twisted pair, and we sell that. It'll be on our product page along with shunts. It'll be actually a little bit different than this one, but that'll be on our product page. Also, speaking of the shunt, typically they are stamped. You can't see this probably in the video, but so this is a 1000 amp shunt at 50 millivolt, and that's one of the settings in there. You don't need a 1000 amp shunt for this 130 amp alternator. Typically it'll be a 500 amp shunt, so 550 milliamps is usually the rating for the shunt. Now, this is an isolated ground alternator, and because it is an isolated ground alternator, we can tap the shunt off of the negative wire. So we'd grab the first point coming off of the negative stud would be going to our shunt, and then this one would go to our battery system. On the positive side, we'd go straight to an appropriately sized fuse, depending on the size of the alternator. And then, for example, a distributor, you could put it in right to a distributor. If it is a case ground alternator, we have to use a different method. You could put it on the negative lug that comes off of the engine, but the amperage wouldn't be accurate. So the best way and the most accurate way to do it is to run it through the positive wire. So you'd come off the positive lug over here, and then from that positive side, you go to your appropriately sized fuse. Now, I don't like to have a metallic object like this that is hot inside an engine bay, meaning that if you accidentally touch it with a wrench or something, it's got positive voltage in it. So it's a good idea to protect it. This is just an AC wiring cover by Blue Sea, so you can just cut some holes here and run your wire through, so you're protecting the positive shunt. Same thing that you do with your battery terminals. Oh, and of course, one of the most important parts, the last wire in the piece here, the thermistor for the alternator. It's just a quick connect here. The wire's a little long. You can coil it, zip tie it, and put it away, but this is probably one of the most crucial pieces of equipment for the alternator to prevent it from overheating. Some people like to put it on the negative lug, on the case. The ideal location would be right on the core, but often that's not possible. So if you can put it on the case right at the back, sometimes you can undo the bolts that hold the case together and put them back, and then put the thermistor on there. That's a good spot for it. Now there is one wire, and I said I would keep this simple. There's one wire that you're probably not going to use, and that's the purple and yellow. That's for a feature out. So that typically isn't used, but there are a number of options that you can do with this wire here. That's it for the alternator side of things. Now I'm going to clean things up a little bit, and we're going to look at the battery side of things. All right, here we are with the battery wiring portion. What I've done for simplicity is, well, I've removed the alternator harness from this, and I've also, the wires that we led back to the alternator from this harness, I've moved over here, and I've also included the optional feature-in wires, which are not going to be a part of this video. We can talk about those at a later time. So on the battery side, the two, well, there's a lot of important wires, but the voltage sense wires are very important, and the location that you choose to land these wires is also very important. So this is what the Zeus uses to measure the voltage at the battery. Your alternator is all the way back in the engine bay, and maybe your batteries are up front 20 feet away. We need to get an accurate measurement of those batteries because there's a lot of voltage drop on the way from the alternator down to the battery bank. So although not required, I still prefer a twisted pair for these wires. And again, very important to put an inline fuse where you measure. So typically on a battery bank, I'm going to have a battery bank, a distributor, and a shunt, depending on if it's a Victron or not, a shunt, and a Class D fuse, and I'll put an MRBF fuse holder, and or we'll just, right after the protected side of the Class D fuse, that's where you can grab your measurement for the voltage sense. And same thing with the negative, like after you come out of the distributor, you can find a spot, you know, so closer to the battery, the better. Now we have this twisted pair, and just for explanation's sake, a twisted pair helps combat interference within the wires, because what we're measuring very small voltages, and there could be interference, say a VHF communication cable, or there's other ways that there can be interference, but a twisted pair can help prevent and shield that from happening. So for a shunt, definitely a requirement. I still like to use them for the voltage sense, but here are the shunt wires for the battery. Now with Victron, I've drilled and tapped with brass screws on the back side of the shunt. Now, to be perfectly transparent, it probably voids the warranty for the shunt, and it may lose a little bit of accuracy because it removes some material from the shunt. But I've done that in the past on the Lynx 500. There's analog leads within that, and I can make another video about that to grab the analog current from there. Basically, it's all to prevent having to add two shunts. Like, you don't want a Victron shunt and then this shunt in the system when it's not necessary. But we can do another video about that. These are the shunt wires for the battery. And of course, these would be led to the front where your shunt is. Another important wire, if you have a BMS that is capable of communicating via a dry contact or a relay, this is the signal wire to the Zeus that is basically, as Victron calls it, allowed to charge. So as long as there is positive power on this cable, the Zeus will be allowed to charge. And if the power is cut on this wire, it immediately stops charging. So it's kind of like the safety switch for allowing to charge and allowing to charge. So on Victron, on Lynx 500, there's an ATC that you daisy chain to the optional relay, and then you go in the app and select that to alternator ATC, and you would connect this on that. But again, we can do another video or another topic on this. And then the same thermistor, you plug it in, and this would go on your battery. And of course, if you have a battery bank, you could put it on the center battery, assuming that one would be the one that would get the hottest. The information will be transmitted via CAN bus from Victron and other brands. But if you don't have that capability, then you can use this thermistor. And I, in some cases, still run it because it's just another safety net, another safety feature. You can independently monitor all of these parameters, whether it's temperature, voltage, current, within the Zeus and kind of keep that safety net in a safe in the safe zone, if you will. Okay, for this last part, I want to discuss about networking the Zeus to other devices. So to start, I just want to talk about a basic CAN bus system, which NMEA, RVC, VE-CAN, they all kind of operate within the CAN bus wiring, if you will. They all have unique requirements. Same thing, NMEA 2000 network as well as a VE-CAN network require the same, and that is to have a resistor at each end of the unit. And so this is a basic NMEA 2000 backbone. So the backbone is the top trunk. This is just a coil wire. So we have a resistor at one end, and these are known as drops. This is where you'd have an instrument, for example, a Zeus or a chart plotter, what have you. Here is another drop, but this drop in particular has a power tap because the NMEA 2000 network needs power, and the Zeus will require power as well on its network. And then we have a terminator at the other end. So really important to have a terminator at each end, and then a power source that is fused at 12 volts, for 12 volts. And then your drops can't be more than 6 meters. The backbone, that I can't remember what the exact number is. I think it's 120 meters, but that one can be pretty long. And so how does that fit into when you want to network the Zeus to the servo, for example? Well, you need a resistor at each end, and obviously a wire, a means of communication between the two. So the easiest way to do it, if you have one Zeus and one servo and nothing else in between, those are the only two items that you want to communicate with. And these again will be available on our site. You want a female resistor, and you can plug that right into the Zeus NMEA 2000 ports. Now you have your resistor at the one end. And then you can grab your RJ45 and go from the Zeus over to the VE-CAN port on the servo. And now this little blue thing that most people think are just a plug is actually a resistor, but it's the Victron style resistor, which is the same ohms as this resistor over here, which is NMEA 2000. But now, if all you have is one Zeus and one Servo GX, you've got a terminator at one end, a communication cable between the two, and a terminator at the other. And now you have a properly set up network. If you just try to connect the VE-CAN straight without any resistor, it's probably not even going to work. It actually works with one, I tried it, but the proper way of doing it is to have a resistor at each end. So this is the most basic form. If you have two Zeuses and or you have a Lynx 500 BMS, they all need to be on the network, and you could have, your CAN bus network can be quite bigger than that with other Victron VE-CAN compatible components. I typically like to build a network within the engine bays. RJ45s are great when you're indoors, but to have one of these plugged into here, I prefer to run NMEA 2000 cables. And so what I would do is build a network. So I'd have my one resistor at the one end. And then we have this servo connected. So here's the beginning of the network. We have a resistor. Our servo is the first one in line. Over here, maybe we have another T, we have another servo coming in, and then we continue our backbone. And then once you get to the Victron makes a cable. Unfortunately, I was out of stock, but maybe we can overlay an image of it. But basically, it looks like this, except the one end has an NMEA 2000 connector. So basically, that allows you, when you're done with your networking, you can connect this NMEA 2000 connector at the one end, and then it goes into the Victron at the other. Now, if all you have is two Zeuses and Servo GX, you put your terminator here. You've got one at the one end, and the one ends here at the servo. Let's say this is a Lynx 500 BMS. You would have another RJ45 that goes up to your servo, and then at your servo, you finish your termination. So you kind of keep going in a straight line, terminator at one end, and a terminator at the other. Now we mentioned that this network needs power. The RJ45 from Victron that has the adapter cable, has something that looks like this that comes out of it. And that is to power the NMEA 2000 backbone from the servo. Now, one thing to note here, if you have a 12-volt system, it will pass 12 volt through the NMEA 2000 network, and that's great. But if you are running a 48-volt system, not all devices on the CAN bus can handle the 48-volt or even 24 for that matter. So then, at this case, what you would do is you would remove the fuse that's in that little wire that hangs from the VE CAN to NMEA 2000 wire. So then you're disabling the power source from the servo to be injected into your backbone, and then you would use one of these and plug it to your 12 volt on your boat or RV or what have you. So this is a power injector. We want 12 volts, fuse at 5 amps or 3 amps, and that's that. But if you have a 12 volt system and you have that Victron VE CAN to NMEA 2000 connector, you can just connect the inline fuse, and then your Servo GX will provide the 12 volt power and to power the backbone. So hopefully this video helped you out. Again, it's very basic. Leave comments in the video if you have questions. I'm sure there's going to be some questions, comments. There's multiple ways of achieving the same goal. I'd like to hear how you like to set them up, and we can do some other videos that are more in-depth on a particular topic. Right now we only have the Arco Zeus on our website, but shortly we're going to have all of the all of the components that you need, like the step-down butt connectors, the shunts, the cases, everything you need. NMEA 2000 cabling. We're going to have a fairly easy selection tool to be able to get the right parts that you need for your installation. Also, this is a generic wiring diagram, one for an isolated ground alternator, the other one for non-isolated ground. And then we can include this, or we can even go as far as having tailored wiring diagrams for your specific needs. That's also an option.
For anybody who's made it this far in the video, we are so thankful for you and your viewership. And if you have made it this far, if you would consider going ahead and liking and subscribing, that really helps us trend up in the algo at YouTube a little bit better and supports this content coming to you. Check the link in the description below for all kinds of different affiliate links that don't cost you anything if you were to purchase anything through those links, but gets a little bit of money flowing our way. So once again, we can keep this content rolling out to you guys. If this is something that you found helpful, and this is something that you want to see more of, some of these more in-depth things using people like the co-owner of the Yacht Rigger, Andre here, this Marine ABYC master electrician, and all the other people that we have here at the Yacht Rigger to utilize on the On Deck channel, please let us know what it is that you would like to see more content of, and put all your questions below pertaining to this particular video and anything that you would like to have clarified. Thank you guys again for watching, and we'll see you on the next episode of the On Deck channel.